Hello everybody and welcome to today's Synopsis webinar. Today we'll be talking about Simpleware Software for point-of-care 3D printing or anatomical 3D printing as well. My name is Karim Gench. I'm the Business Development Manager for the Simpleware group within Synopsis. And with me today is Ross Cotton. He's the Application Engineering Manager for the Simpleware group within Synopsis as well. So to give you a bit of background on Synopsis, it is we're a rather large company with about 3.7 billion in revenue, projecting to hit the 4 billion mark at the end of this fiscal year. We have about 15,000 employees, and it's a very large software company with a global presence, and has been a leader in our area for a long time. So in terms of the Simpleware product group within Synopsis, we are developers of a high-end 3D image processing software. We have dedicated sales, support, and services teams across the globe. We work with customers in clinical, life sciences, materials, manufacturing, and more areas as well. So the focus of today's talk is Simpleware Scan IP Medical, which is for clinical image data processing and point-of-care 3D printing. So Simpleware Scan IP Medical is Synopsis's flagship CE marked and FDA cleared medical imaging processing platform. So this is a platform that allows you to import data such as MRI, CT scans, any DICOM format into our software platform, perform your analysis, perform your segmentation, and then generate models for your analysis, whether that's measurements, 3D printing, simulation, etc., or design. So recently we have gotten clearance from the FDA for the end-to-end point-of-care 3D printing solution, and we have this on our website with all of our regulatory information and the 3D printers that have and their materials that have been cleared. So taking a quick step back, I just want to define point-of-care 3D printing for our current context today. So in general, when you hear about healthcare 3D printing, this can be many things. It can be things like anatomical 3D printing, which I'm sure pretty familiar with, cutting guides, implants, and things like that, which fall under more of the I would consider additive manufacturing. So more of the metal additive manufacturing, as well as people developing jigs and guides and things of that nature. So that's kind of the umbrella of healthcare 3D printing. So for our current context, we're looking at hospital-based anatomical 3D printing. So this is we refer to this as POC 3D printing. So although we say hospital, this could be within a medical device or any kind of life sciences context where this is being performed. And typically the anatomy types, the biggest one is bone or orthopedic, looking at the hip, knee, different parts of the head, spine, shoulder, any kind of orthopedic application. Then typically followed by cardiac or vascular, any other organs within the body can also be used for 3D printing of these anatomies. And typically the surgical specialties are orthopedic, cardiothoracic, CMF or craniomaxillofacial reconstruction, oncology, neuro applications, etc. And typically these are in-house or they can be outsourced to service providers to perform the actual printing. Sometimes a hospital or a medical device company doesn't want to do this in-house or invest in the hardware and software to do this, so they outsource this to a service provider. And on the right, from a fairly recent report from the Society of Manufacturing Engineers looking at additive manufacturing and 3D printing, typically at the top it's used for surgical planning, followed by patient education, clinical training, testing and verification, and then surgical rehearsal. And then after that, it quickly falls off into other categories. And looking at the benefits of these anatomical models, it's improved patient outcomes or our patient education, better preparation, better communication with patients, reducing OR time. So every minute you save in the OR will save you a significant amount of money, reducing cost overall, and then minimizing complications before falling into other categories as well. So we can see there's quite a bit of value from this. So looking at the emerging hospital market, currently there's roughly 300 out of the 5,000 or so eligible, what we would consider eligible hospitals in the US with point of care 3D printing facilities. So the value of proposition in the hospital and patient is quite high. So it has reduced OR time and cost, improved outcomes for the patient, and better patient communication. And then there's some intangible values, things like surgeon confidence in the surgical plan, public relations, brand enhancement via innovative use of technology, showing that you're using some new technologies to help patients in these uncertain times. It can be pretty scary going into these very complex and large surgeries, and it helps a lot and gives patients a lot of confidence to have an actual physical, tangible model of say their organ or different part that's going to be undergoing this procedure. So the main drivers for POC labs is increasing as well. There's more demand for personalized patient-matched devices or plans. There's more acceptance of anatomical models in general and guides for surgical planning. And also another thing that's very important is the current procedural terminology or CPT codes. So these are the codes used for reimbursement. So currently 3D printing, point of care 3D printing is at category 3 for anatomical model and guide use. And that was approved back in July 2019. And there's you hear different dates and different estimates, but it's estimated that this will reach category 1 by 2023. And this would allow full reimbursement. So that would definitely help this market really take off and really be used much more in general. So bringing it back to Simpleware Biomedical for POC anatomical 3D printing, the idea here is to have an integrated end-to-end POC solution. So you have your MRI or CT imaging, you want to bring that into a platform to do the image processing, generate your model, and then send it off to a 3D printer for the anatomical printing. And then from there you can do your surgical planning, patient education, etc. So the Simpleware Biomedical workflow is where it can be bundled in with 3D printers into that workflow. And so you can capture the end-to-end image to 3D printing workflow within your organization. So if you have the software and then the hardware, you can put them together and really have a nice workflow. So the image data would be imported into Simpleware, Biomedical, and then you using our 3D printing toolkit, which my colleague Ross will demonstrate, you can provide print-ready models for anatomical 3D printing. So the benefits to the hospitals are things such as improved patient outcomes, planned and prepared surgeries lead to faster operating time and quicker recovery. You get a better quality of results. You have high quality anatomical models to practice and plan complex surgical procedures, and then reduced costs. So Simpleware Biomedical eases the the ease of use of the software and built-in automation can save on segmentation and model prep time, all within a single environment. There aren't multiple softwares. Everything is integrated into one software environment. So what does Simpleware do for POC 3D printing? So on the right here is a graphic kind of outlining the different things that can be done. So starting from the top, model generation, STLs, 3MF, different formats that can be exported for typical 3D printers can be generated. You can import 3D or 4D image data, for example 4D cardiac CT, all of that can be imported. You have CAD and image integration, so you bring in CAD geometries as well. There is quite a bit of scripting and automation. So scripting in C#, Python, really to automate your workflows. And we also have machine learning based AI tools to fully automate the segmentation process. And those are on the Simpleware platform. This isn't up on the cloud. You don't have to worry about sending your data anywhere. It's all done locally, and it's put directly into the user's hands. And there's different levels of customization that we can do for these tools. But I should mention also that the machine learning based AI tools are not FDA cleared. Everything else that I'm talking about is just those AI tools that are not. They're for R&D purposes only and would require a separate type of clearance. Moving on, you can do measurements and analysis, and then also very important, which I'm sure a lot of people here struggle with, is segmentation of the anatomies from the image data. So again, we are US FDA 510K cleared and CE marked. We have an integrated 3D printing toolkit all within the ScanIP medical software platform. Again, no separate softwares to prep your models for 3D printing, correct STLs or anything like that. None of that is needed. It's all within the single platform. And then also we have automated segmentation and various levels of that. And I'd be happy to discuss those in detail should anybody have any questions or wanted to discuss that separately. So also in terms of what's currently supported, 3D printers and materials from our 510K clearance, we have Rise and Stratasys with different 3D printers and materials as listed here, and then the applications are orthopedics, maxillofacial, and cardiac applications. So with that, I will pass it off to my colleague Ross Cotton, and he will go over our 3D printing toolkit and demonstrate it for you. Thank you. Ross?
Great, thanks, Grim. So first, just quickly introduce myself. My name's Ross Cotton. I'm the Applications Engineering Manager for the Simpleware products at Synopsys. And it'd be my pleasure today to talk you through the new ScanIP 3D printing toolkit, as Grim just mentioned. So I'm going to run through that toolkit in just a second, but obviously ScanIP is quite a wide-ranging program, and essentially it can take in any DICOM medical imaging and process it through to 3D models and everything in between. So all your visualization, measurements, analysis, segmentation, image processing, all that is all included within ScanIP. And the 3D printing toolkit is a new addition in our June release last month. So it's relatively new, but it's all been built towards this FDA clearance and enabling you to go from DICOM to 3D print, so the end-to-end solution, all within one package. So you don't have to go and export an STL, do all your fixing, editing, prep in a CAD software or other softwares outside of your segmentation software. So we're really streamlining the workflow with this new addition. So we've taken some tools and customized them towards this 3D printing application. So I'm just going to talk you through those new tools and give you a very brief demo of how they look and work in the software. So the 3D printing toolkit has its own new tab in ScanIP. So if you're familiar with ScanIP, we have a ribbon-based interface and we have a new 3D printing tab, which you kind of work from left to right, going from your segmented mask through to a surface, tessellated surface, and then you've got your preparation tools, analysis, inspection, and then obviously you export as well to your printer. So I'll walk you through a few of these through these slides. So the first one, all the tools work on tessellated objects. So we've extended the support in ScanIP to work with tessellated objects. So you can move from your segmented mask, essentially a collection of voxels, through to your new surface object, which is then moved into the surface objects. And there's a couple of buttons here to convert mask to surface, and it's all just using those two buttons there. Once we've got that tessellated surface, what we call a surface object in ScanIP, we can then go into the prep tools. So we've got 4 of these. The first one is embossed text. So you may want to add some physical text or colored text to your model to enable more traceability and identification to the print. So if you're printing multiple things at once, you can be sure that print belongs to that patient ID. So we've got a range of tools. Again, I'll show you this in the demo quickly, but you can either have it embossed or debossed, separated or merged with your anatomical segmentation. We have quite a nice widget, which again, I'll demo in the software. The hollow tool, again, you don't necessarily have to apply all these to your model. They're all kind of here for various applications, and the hollow tool is primarily there for cardiac applications where we've segmented the blood pool. For example, the red object on the left, we can apply the hollow operation, which then either can be inwards or outwards. Typically, it would be outwards, so it hollows outwards with a set wall thickness. In this case, it was about 1.5 millimeters. And that creates you that hollow model, which gives you that inspection within inside the model. The logical next step for kind of a lot of hollowing models, and this is also useful for other prints, is cutting. So we've got some tools, which can do like lasso and polygon frustrums to cut through your surface to open up either vessels, like you can see here, or maybe add inspection kind of windows, and you can then kind of use any kind of polygon or lasso shapes, freeform shapes to cut through the model and give you the output, which you can see on the right there. Finally, we have create connectors. So this is really useful both in orthopedics, CMF, and also cardiac applications where you might have fractures or vessels and bones together, or very small floating vessels which you need to stabilize for the print. So we know, for example, this mandible we can see on the left has quite a bad fracture. We know when we print it that it's quite unstable, and if you're handling it or posting it or sending it in various ways, then we need to add some connectors to strengthen the print. So we can use a nice tool we've got, which you can just, in a couple of clicks, add these connectors. And then again, you can either trim it or leave the overlap depending on the 3D printer technology you're using. Some prefer overlaps, some prefer trimmed connectors so there's no overlap. The picture on the right is a cardiac model where we've used connectors to stabilize the descending aorta there with the heart blood pool. So it's a very nice, easy way to create these connectors to stabilize models or to make sure things are positioned accurately in their right orientation and space from your segmentation. The next tool we have is more towards orthopedics and maybe CMF as well. We call it grayscale visualization. It works obviously best from CT, and it enables you to put some quantitative information on the surface. And this is really aimed at your multicolor jet printers, which can take advantage of the multicolor printing. So we can add in very useful bone density and bone quality information to your print. So we have a technique which we can use to project inwards and sample the Hounsfield units from the surface inwards. Say in this case we set it to 4 millimeters. So we can sample 4 millimeters within the depth and give you the average, the max or minimum Hounsfield units, and then put that onto the surface for you. So not only do you get the bone density at the surface, you get the bone density for, in this case, an average over the 4 millimeters inwards, and we can project that back onto the surface. So you can see the red hot spots here are very kind of thick cortical bone, and I guess in contrast you could have very thin cortical bone. So on the surface they're very similar, but this technique allows you to both capture thickness and quality at once. So it gives you a very nice indication of maybe where the best place to put a screw is in this model. Also relating to color printing is we have a new tool called color proofing. Essentially it's like a print preview like you get in Word or PowerPoint. We can add in color profiles from your printers in the kind of standard format ICC, and I think there's a few others, but you can add in your color profile. For example, maybe you've got a variety of different cartridges you've put in depending on the materials and transparencies you're using. And obviously those can have an effect on the final color print. So we can then preview that and how it looks, and making sure what you kind of see is what you get, and what cartridges you're using will give you something reasonably similar to what you see on the screen. So it's a really nice way of making sure what you see is what you get in the final physical print. And finally, the main important thing is checking printability. You don't want to be exporting files with issues. The nature of ScanIP is that it's very robust. We use a lot of our technology we developed over the years to generate very robust and printable surfaces with no errors. So this is more of a confirmation dialogue when we get to this stage, so that we don't need to necessarily fix because it's just more of a confirmation of the quality. So we can check the status, things like is it watertight or bad orientations, self-intersections and non-manifold edges. Then information on the size of the model, so the number of polygons, maybe you have a limit on the number of polygons. Also the extent, you want to make sure it fits on the print bed, and the number of connected surfaces, you want to make sure there's no floating bits perhaps as well. And finally the wall thickness, so if you've got small resolution you want to print, or you know the minimum wall thickness the printer can print, you can set that here and preview it. So you get an idea of whether small thin features will be printable with your model, and you get a nice kind of green and red mapping on the surface, and some annotations as well if needed to find those regions. Finally, the next one is obviously export. We export all the major formats from 3MF, STL, or OBJ in the Biomedical software. We also export DICOM encapsulated STL back to PACS as well. So all of them should be covered. The 3MF OBJ obviously support color, the multicolor, and that's all being kind of checked and verified with various print manufacturers. So with that, I'm just going to jump into a kind of 5-minute demo of the tools and give you an idea of how they work. It won't be too extensive, but I guess please do feel free to either get a trial or download the software, get in touch with support to find out a bit more about these tools and how they could be helpful for your end-to-end workflows. So the first one I'm going to bring up is this mandible case. It's worth pointing out, these data sets I'm showing are available as our tutorial data sets, so you can get a trial, work through these tutorials, step-by-step instructions to go through these models. The tutorials, can be found from the welcome page, tutorial guide, and then if we go down, you've got various kind of segmentation ones, medical segmentation, medical 3D printing. So we've got a couple of tutorials here, and if you click on it, you can walk through these, and it gives you the kind of step-by-step right in front of you on the screen. Before I just jump into that, obviously ScanIP has got a range of tools, and I just want to quickly highlight that first, as I think Karim touched upon in the slides. So we can import from a variety of locations, primarily for medical anatomical 3D printing. You're probably interested in DICOM and PACS. So PACS is available with the ScanIP, Simpleware ScanIP Medical FDA cleared and CE marked software. So those two will bring your data in. We'll look at something like this. And then for kind of segmentation, we have a full range of kind of manual semi-automated tools to achieve that segmentation, all being designed with the user in mind and based on user feedback for usability. So we've got a really nice selection of tools here to segment your models. As we mentioned, we have AI, machine learned, automated segmentation. Again, this is not part of the clearance, but it gives you a really good starting point on maybe some tricky models. So it's something worth to consider, and please do get in touch with us for more confirmation on these tools and the regulatory aspects. But we have them from ankle, knee, hip CT, knee MRI, and heart CT. And again, there's further information of those on our website. And then we have another set of tools. So this is obviously the full suite with all the modules. They're aimed at doing different things with your segmented data and images through to STL exports, finite element meshing, computational fluid dynamics. We've got a full range of measurement tools from obviously simple measurements through to center lines and shape measurements. And obviously today we'll probably just jump to it now, the 3D printing. So 3D printing tab, as you maybe saw on the slides, is this simple group of tools. And what we're going to do here is just show you a few quick operations. So in this data set, we've already segmented the mandible, so that's the starting point. So that's the kind of preparation you would need to do before you jump to this tab. So we've segmented the model, and we can show that on the screen, like so. And the first thing we need to do is convert this to a tessellated surface. So I'm just going to use some additional settings here to decimate the surface just in terms of speed and time. So I'm going to reduce it to about 100,000 triangles using the kind of additional settings in the 3D preview tab. Not always necessary, but it's just purely for today's demo, just to make it run a little quicker so you can see some results. And with this data set, I'm just going to run through a few quick tools to give you an idea of how it works. So there we go. That's the decimated surface. First thing we're going to do is master surface. And I'm going to click Generate Surface. Creates a new surface object in our dataset browser here. That's what we'll now be working with. With this one, I'm just going to show you the emboss text tool quickly. So maybe you want to put some identification on this relatively flat surface over here. It doesn't necessarily have to be too flat. It will move with the contours of the model. Text, I'm just going to type something like patient 1234. We can choose our font. It will detect all the fonts on your system, but we'll just stick with Arial for now. The size, a little tricky to determine, so we can just go ahead and position this and see what the size looks like. Obviously that's quite big already. So what we're going to do is just position that and make sure it's the right way round. Let's move it away from the surface a bit. Let's reduce the size. So obviously 10 millimeters is a little too big here. Maybe something like that's more reasonable. And we can kind of make sure that we're kind of positioning it where we want it. And we want to either emboss or deboss. I'm just going to simply emboss this. And the kind of options you get is the depth. I want to maybe just put a 1 millimeter depth on it, and I want it to. The overlap is more of maybe an advanced option for when you're separating surfaces, which you can do obviously down here. You can separate it to make it a separate surface for coloring purposes. In this case, I'm just going to union, and we can see how that looks. So this process will create our text on the model as still as one surface. And there we go. That's the embossed text. A little tricky to see when it's the same color, but there you go. You can see how it's kind of looked, and it's got that 1 millimeter depth on there. The next one I want to show is the connectors. Again, we need to maybe connect this model to make it more stable, just from experience with printing this one. So we go to create connectors. It's a very simple tool. Go to create, and then we can click where we want it to start, where we want it to end. We can have a look at that more closely. It will automatically overlap. We can choose the size, so maybe we want it slightly bigger. Click on the end here. You can adjust the positioning, so you can make sure it overlaps, or maybe move the position. The middle one will move the global position, and then obviously we can check the other side as well if we need to. But that looks good. And then we just want to say whether we want to overlap it or trim it. I'll go trim for now. So this will create a conformal interface. It essentially does a subtraction. So the connector minus the mandible mask, which we've kind of ticked in the list. And that'll make sure there's no overlaps. That's done. I'll just fly into this area here. And if I just press the wireframe, you can kind of see that has been trimmed there. And there's no overlaps. So again, depending on your 3D printing or the printer and how it works with overlaps or trim models, you get both options here. And the final one I want to show you on this one is the grayscale visualization. This gives you that bone quality information inside mean, say 4 millimeter depth. So it will project inwards by 4 millimeters and give us the average on the mandible mask, not the connector. There we go. Obviously, the more dense it is, and then also in combination with the thickness of the bone, we get information on that, and you can adjust the color scales here. And this is all taken through and exported with your 3MF or OBJ file as it looks currently. Also, you can adjust the sliders to making sure it's kind of got the right range you need, and so on. I'll maybe just check out the printability of this one. So it's going to give us some information that it's watertight, no barrier orientation, so it's all good. The size of it, and then we get the wall thickness. So obviously it's kind of warning us a little bit about the text here, because that's kind of around that 1 millimeter mark anyway. So it kind of gives you that kind of warning up front that this may not come through depending on the 3D printer you're using. Obviously, if you can handle smaller features, then you can just adjust the threshold here as necessary. And the final quick demo is on the cardiac case here. I've gone ahead in time. I've gone from the blood pool segmentation. I've created a surface object, and then I've just used the hollow tool from the 3D print tab. So master surface, I've used the hollow. You can see the contours here of how it's created the hollow model. And then we can go into our surface object here. This one I want to use the cut tools. Very nice to use. We've got a simple mode and advanced mode. simple mode, we can simply maybe cut through these ends here using the polygon tool and then close it, and that will cut through using that polygon. This will expose the edges of the vessel like so. And then down here, maybe we can put an inspection window in, again, maybe using the polygon tool. There's various things to do. In the advanced mode, you can do things like make copies and reverse the cut, so you can preserve the cut part as well. But that will give you that nice cut and visualization window in to the blood pool. Again, then you can go to check printability and obviously export scene to disk, again using all the different export formats. I'll finish up there. Thank you for listening into the demo, and hope you've seen today that you can easily go from DICOM to segmentation and through to a print-ready model using ScanIP, and we really look forward to hearing more feedback on how we can streamline this further for your end-to-end workflows. And with that, I'll just put the slide up for the Q&A section. Essentially gives you information on the 30-day free trial. You can get personalized software demonstrations and support. You can get more information on the regulatory and products on the website, and there's some contact links at the bottom there. So please do get in touch, and we look forward to your questions coming in, and we'll now launch the live Q&A. Yeah, so a few coming in. So the first one we've got here, can you explain how the workflow can be automated?
Yeah, so I guess I can take that on. That's where it ranges with what we can do for everywhere from, we have split merge tools, different segmentation tools that can help with kind of semi-automating it. And then we get into things like scripting, Python, C#, using scripting to anything you can click, you can script within the tool. So you can make wizards and help people along. And that's all within Biomedical, the FDA cleared CE mark version of the software. And then going a little beyond that is when we get into our machine learning based AI tools. So we have off-the-shelf tools, AS Ortho, AS Cardio, where you can do automatic segmentation of the hips, knees from MRI, CT scans, the ankle, the heart, and we have more in the pipeline coming, but those are not FDA cleared. Those are more for R&D purposes, but we have customers who use them for their workflows, and especially within the medical device industry, and they have to clear their workflow anyways, so that's fine for them. And then the next step is custom modeler. So that's where we train a tool specifically for a customer. So if you have a high throughput and you have the data, we can train an AI tool specifically for you and really get to the 99% level of one-click segmentation. And this is for people doing hundreds of thousands of CT scans per year. So yeah, that's kind of the range of automation that we've got. I don't know, Ross, if you've got anything to add to that.
No, I think you covered it really well. I think in terms of the support side, we're more than happy to help you in that area and support you on that and provide some examples and help you build your scripts, or as Karim mentioned, into the kind of more consultancy side and custom modeler, where they're kind of customized to you. I guess obviously with anatomical 3D printing, they're slightly more difficult to capture because they are maybe more unusual. So hopefully the combination of the off-the-shelf image processing segmentation tools combined with maybe some AI and a bit of kind of automating repeatable operations, we can really speed up workflows quite significantly and reduce that bottleneck of segmentation.
Also, I should mention all of our AI tools are on the tool itself. You don't have to upload it to an external cloud server. A lot of people have a lot of sensitivity with data, especially uploading patient data to the cloud is a big no-no in certain areas. So this is all performed locally. So that's not an issue.
Yeah, and on
so
standard
following
laptops
up on,
as well. That's the other thing. Yeah.
You don't need a huge workstation to run it. Russ, I don't know, maybe we could just do one more question and then we can wrap it up from there.
Yeah, so maybe do I need any special additional modules for the 3D printing tab?
Yeah, I think I'll let you take that one. You probably know that better than I do.
Yeah, I think it's a really quick one. It's all included as part of the Simpleware Scan IP medical license. So no additional modules. It's all included. Just need the one, and depending on your workflows, you can add in more. If you're doing some more complicated prints, we do have an extended surface tools module called the CAD module, and you can do a lot more complex operations to build your prints.
Great. I think we're running on 40 minutes, so I think we'll wrap it up there. I want to thank everybody for your time and joining us for this webinar. If you have any questions, reach out to us. We're happy to have a discussion with you on that. If you are from a 3D printing company and you want to add yours to our list of approved 3D printers, let us know. We'd be definitely interested in talking to you. With that, I guess I'll leave it there. Ross, unless you have any wrapping comments you want to say?
No, just thanks for listening, thanks for your time, and really look forward to hearing from you. And we'll be ready on the kind of support side to answer any questions you may have during your evaluations or during your license. So thank you.
Thank you.